And we're gonna go and share a new piece. So I'm now gonna go back into my class notes and we're gonna start chapter 7. So we're gonna look at 7.1. So I'm gonna grab the 7.1 Google Drive notes. All right, so we're now in section 7.1 notes. This is about statistical inference. Statistical inference is where we're doing something called either hypothesis testing or confidence intervals. And so what I want to do is talk about what is the purpose of confidence intervals and what is the purpose of hypothesis testing. But I do want to bring up first the fact that, and I think I mentioned this last time, the ASA, the American Statistical Association, has actually wrote a paper last year that says we should not be doing basically hypothesis testing anymore. Now this is fairly new stuff, and so we haven't changed curriculums and all this stuff, and we still see a lot of reports that are out there of people doing hypothesis testing. So this is not something that is it's something really new that we're now dealing with. So I am going to still teach you about hypothesis testing and what it actually is about, but I'm also more important about what confidence intervals are. So what the purpose of a hypothesis test is to make a decision about a parameter from a statistic. So all you're going to do is say, hey, this is the difference, this is what's happening. That's all it is. A confidence interval, and this is why these are a bit better, is to estimate a parameter. Remember, a parameter is a number from a population. A statistic is a number from a sample. So we're going to take our little tiny sample to tell us what the big one's doing. And a confidence interval's purpose is to estimate a parameter from a statistic. So that's really the whole purpose behind these two, is one is to just make decisions about it, and a confidence interval is actually just to estimate. So as an example, if we wanted to look at what % of people are planning on voting in the election this fall, then that would be, we could take a sample and ask a bunch of people if they're going to vote in the fall, but we don't know until the voting actually happens of what really happens. But we can estimate it. We can say, hey, we think this many people are going to vote based off of this idea of a confidence interval. We can say, we think it's going to be this high or this low. We can't be sure, though, until it actually happens. But it gives us an idea. And so what we're going to be looking at is kind of this idea of confidence intervals and hypothesis testing for the rest of the semester. This is what we do. This is what statistics is all about, is figuring out what parameters are from the little tiny statistics. So what's happening in the big giant population from these little tiny samples. Right now, we're dealing with the coronavirus. And we're seeing a lot of people talking about, what's your chances of dying from this? That is an estimate of your parameter, how many people die from the statistic, how many people have actually died. So we're actually seeing that right now going on in this day and age to us every single day of what that percent is. And it does depend on where you're living. So in South Korea, it's about 0.6%. In Italy, it's about 8%. So it depends on where you are as to what's happening. In the United States, we don't know. We don't have enough data yet to actually say what it's doing, but we can estimate it. We can estimate what's your chances of dying from it based on this. We can also look at different ideas behind that, like different age groups. I just saw one that talked about different blood types. Seems that people who are A seem to have blood type A seem to be more susceptible to getting the coronavirus. I don't know. I didn't think the data actually showed it yet, but we're looking at all these different things. So what I want to do is I'm going to actually have us go into this little app that I'm going to be working with to kind of talk about some ideas. So if you want to, you can go here. If you don't, you can just watch what I'm doing on my screen. That's fine, probably. And I'm going to look at income poverty and home type. So this is our NHANES data frame that we've been dealing with. I'm going to come over here to income poverty, and I'm going to pick home type. Here's home type.
Oh, you just passed it.
Oh, there it is. Okay. Now, I'm probably wondering, what are those things? So I've talked about Codebook in the book a lot. I'm going to go to the Codebook on this little app also. And again, this is the National Health and Nutrition Evaluation Survey. Got it backwards. All right. And I can come down here and see what all these variables are. So income poverty is the ratio of income in dollars to the poverty level of income. So in other words, we say this is what we consider poverty level. And then we can look at how much you have compared to the poverty level. And if you're at 1, that means you are at poverty level. If your ratio is above 1, then you're above poverty. If you're below 1, then you're below poverty. And then I also wanted to look at home type, and home type is, does the participant own or rent their home? So those are what those things mean. And here's my data. So I have a sample here from this NHANES of 50,000 people. I have a sample of size 50. And these are my 50 people here that own the home. And these are the 50 people here that rent a home. Okay. And I'm looking at this and I'm wondering, is there a difference between people who own and people who rent? So what might help me to figure that out? What might be something I could look at to calculate that would help me figure out, is owning a home, maybe I want to know if owning a home has a better income poverty level than renting a home. So what would be something that could help me figure that out?
Find the mean of each.
Okay, so let's find the mean. I can actually do that. Just click of the button, and there's my means. So this is the mean of these 50 numbers here. This is the mean of these 50 numbers here. So does it look like there's a difference?
Mm-hmm.
Yep.
Yeah, looks like there's a definite difference. What if I did a new sample? Does it still look like there's a difference?
The difference seems to remain about the same, but the mean itself changes.
Yeah, the mean changes a little bit. And I can keep doing that. Those aren't as different. Those are a little different. Those are kind of different. I can do different samples. And this is what I want to show, is our samples actually are different. They're always going to be different. And so I can look at that and see what information is going there. And I can see, hey, sometimes they're pretty close and sometimes they're a lot farther. And so the question is, how do we determine if we happen to have a difference? How can we say that these are in fact different? Or maybe they're not. Maybe it could just be by chance we see a difference and there really isn't a difference. Also, if I increase the sample size to maybe 200, do I still see a difference? Yeah, I still see a difference even for a bigger sample. What if I took a really small sample?
It seems like the difference in mean, yeah, like that, the difference in mean has a much higher chance of being drastically different from a previous sample.
Yeah, because we have a much smaller sample. So this is why the sample size is important to understand, because your sample size can actually change what happens. But a really large sample can show a difference when there really isn't one. So be careful with that also. So we want to make sure we don't get too big, and we want to make sure we don't go too small. I'm going to go back to my 50.
A large sample can show a difference when there isn't one.
Just because you have a sheer number of data points, you can in fact get a difference because of some of the other calculations that go into it. So the sample size turns out to be part of the calculation. And that's all why.
Well, also a good way to be able to tell it would probably be like getting an actual sample size of 50 for own and a sample size of 50 for rent, because it looks like for the sample size of 50, they just draw random people. And if you look at the dots, it seems like majority of the time there's less people on the renter side than there are on the owner's side for majority of the ones we're seeing so far.
You're right. I agree with you. So we do want to do that. So we can actually do what we call a stratified sample, where we do actually do that, where we take 50 people in the own and 50 people in the rent. Okay. Okay. So that was a very good notice to look at, is that we can do that kind of information.
Yeah, and that seems to be a lot more accurate then.
Yeah.
I mean, it didn't really change anything. That own seems to have a bunch of people at 5 and above, it seems like.
Right. So we do have a bunch of people up here, and they're all just there, and there's nothing really above there. There aren't that many people that are up there in the rent section, right? There's only one up there at this moment. So we do see a difference there, but we do see a lot of people who are down here in the poverty level that only rent. So what we have to figure out is, what do we see as a difference between these? And how do we tell? So I'm going to go back to my notes for a moment. And I'm going to talk about how do we actually tell what's happening. So I'm going to write in here a little bit about the fact that I want to know, I am looking to see if people who own a house have a higher income to poverty ratio than people who rent. That's my question. That is what I want to know. And so what we usually do when we're doing any kind of testing is we start with a question. We need to have some kind of idea of what we want to do and what we're looking at. So you always want to start with that question. Then you go and collect the data and see what happens with the data. And so we have this data going on here. We can see from the data it looks like it. But the question is it real? That's my question, is this really a true difference, or could it just have been something we saw by accident? And that's where hypothesis testing comes into play, is what is actually happening here. And what is a hypothesis, by the way?
Educated guess.
An educated guess. There we go. Hypothesis is an educated guess. So my educated guess is that people who own homes are more well off than people who rent homes. That's my educated guess. That's just what I'm trying to say. So we're going to test that hypothesis. We're going to look to see, am I right that this is happening? And there are actually, in statistics, there are two hypotheses. I'm going to start with the alternative hypothesis, which I hate the name of that. I think it's a terrible name that we've given it. It's the name that's been stuck around for years, and I actually think it's a terrible name. I prefer the research hypothesis, because it is actually what I'm trying to make a guess about. It's my guess. So my alternative hypothesis is my guess. It's my educated guess.
So why don't they just call that the hypothesis?
Because statisticians who came up with this did some weird things.
Oh, okay.
And I can't give you a good answer as to why they did it. I have a friend of mine who's actually trying to get rid of it and just going straight to, well, we're actually trying to get away from hypothesis testing altogether. But we have to kind of work with these two different hypotheses. But this is actually what I want to do. So it is my educated guess. The symbol we use for it is HA. I don't know. It's because alternative hypothesis H today. If you want to make it a subscript, you can. There's a way to make subscripts here.
I don't know if you
Google
can in Google Docs. I've never figured it out.
Yeah.
I
Google
think
Docs and Word have different things. Word actually, you can do a subscript quite nicely. I don't care if you make it a subscript. It's HA. So we're good. And again, it's what you're trying to guess is happening. Your null hypothesis is the one that statisticians came up with. And this is the one we actually use to kind of do the material in the course and figure out how to do a hypothesis test, I should say, not in the course per se, because it's not just used in courses, it's used everywhere. And what actually this null hypothesis is it's going to be the assumed to be true hypothesis. So you're going to assume, sorry, I'm going to unbold it. Assume this to be true. That's the first thing we're going to do with the hypothesis, the null hypothesis. We're going to assume it's to be true. And it's basically saying that the difference you see is by pure chance. In other words, you could see this happening when there really is no difference. It's just by chance it happened to happen. So like I could say that by chance, there is no difference in income poverty level of the people who rent and people who own. That is what I'm seeing is just happening. What I see this change going on, but it's just by chance that it happens. It really is no reason it happened. The coronavirus seems to be affecting people who are elderly more, but we could just say, nah, that really isn't true. It's just, we're going to assume it's true. We're going to assume that that's just not true. So we're going to assume that really there is no difference. So really what this is saying is there really is no true difference. And that
difference
is what
the
the null hypothesis is. What was that?
And what do you mean by difference? Is that like the income to poverty ratio, like the difference between the owning and the renting?
Between the owning and the renting. So in this example,
oh,
there
so
is
it's
no
like saying, well,
difference.
that sample that we got saying that people who owned had a higher ratio than people who rented, that's just by chance.
Right, that's just by chance. That there really wasn't a difference, it's just by chance we saw that happen. So in this case, I would say there is no difference between income poverty level for people who own as opposed to rent. So this is kind of what we have. We have this kind of idea, this null hypothesis. The symbol for a null hypothesis is H sub 0, because that's H sub not. Null means not. So that's kind of where it came from. So some people use the alternative hypothesis as H sub 1, which I think makes it look like it's not important at all, whereas it's actually the one that is important. So I'm going to leave it. This one is H sub O, and this one is H sub A. A lot of people also use H sub A, so that's kind of where we go. And what we have to do is we have to figure out how do we go about figuring out how to write all this stuff and do all this information and do these hypothesis testing. So we have a lot more stuff to go through, and I want to start with this example next time to kind of talk about. I don't want us to spend too much time today. I think we've had a long day, and so I think we're going to stop here and see where we are, and then next time we'll come in. But I want to talk a little bit before this. I want to stop sharing for a moment, and then I'm going to stop recording, and I want to kind of